everybody, the other day I made a list of all the advantages to an ICF system. Now, we're a huge fan of just doing ICF right up to the trusses, and so I was jotting it all down and I was like, man, there's a ton of advantages, more than I'd ever thought. I came up with 20 plus quite easily. I'll go through them right now. You see I made some drawings behind me, I'll refer to them. It's not necessarily in order and I'll probably jump around a little bit, but you know, I'll do my best to just cover everything and the advantages to it and compare it to other systems as well. So maybe just a lowdown. An ICF wall is stands for Insulated Concrete Form. So here's, you know, a block that is commonly used. 2 3/4 of foam on either side. You fill it with concrete. You know, there's a lot of parts to the system, but that's just the gist of it. I'll refer back and forth to this as well. But so just to get started is, and like I said, probably not in order, but that's okay. So number one, it's a monolithic wall system. So what that means is it's just one continuous unit. So when you're pouring the concrete, you know, you have the rebar in there, everything connects. After it's cured, it's basically one. So even with your footing, so this is your footing, which is basically sits at the very bottom. It's like the base. It spreads the load of the whole building, and that's what your wall sits on. Now you pour your footings first. You have rebar and all there, but these are called dowels, and they connect your footing to your wall. Now I'll go through why that's important and all that. But when it's all said and done, it's monolithic. It's one piece. You don't have different components. It's not a panel system where it's just a bunch of panels fit together. You know, I think that's it for that one. Okay, so number two is easy attachment for drywall or exterior products. So these are snap ties. They're every 8 inches in this system. They go through the foam is actually formed around the snap tie. So these are designed to hold rebar. They're designed to take the pressure of the concrete when you're pouring, and then they're also designed, they have these little X's on the foam to show you where they are. And when you're stacking your block, you always want your X's to line up so that when you're doing drywall and stuff, it's easy to attach to and you don't have to guess. But the snap tie is just 1/2 inch underneath this foam. So, and that's inside and outside, so you can put siding on, you can do stucco, you can do acrylic stucco right on the foam, you can cement board, whichever, you know. And on the corners they have lots of plastic to attach to for corners, so if you're doing smart trim and stuff. Plus it's every 8 inches, so even on drywall you don't have to worry about cutting and landing deadly center of one of these, because worst case scenario is you're 8 inches away from a screw point, which if you're doing wood construction, 16-inch centers, you know, you're 8 inches in between two studs anyway. So hopefully that makes sense. Okay, so easy to attach to. Number three, so there's more rebar, which is more strength. Okay, so here's my little system. I got my conventional system set up, and I got my ICF system. Now I'm going to go off based on what we do for an ICF system and based on what I've seen in a conventional system. So more rebar. Okay, so in a conventional, depending who's doing it, but typically they just do 2 rows of like 10 mil rebar at the top, 2 at the bottom, some dowels that connect it. Like I said, depending on what you're doing. But what the rebar does is, concrete has like a crazy amount of compressive strength. You can't, it's like, well, maybe not impossible, but super hard to compress and have it crack or break. Now it doesn't have tensile strength, so if you're trying to pull on it, it'll crack and pull apart, right? So that's what the rebar does. Rebar gives it strength, so when there's pulling pressure, it can't break or pull apart, right? The other thing that rebar does is if it does crack, you know, because concrete will always crack, it'll prevent it from like breaking and shearing away from itself, or like in a wall, it won't pull or it won't shift either way. So that's what the rebar does. Now, what we do is we do 3 rows of 15 mil rebar in the footings, and we do it on a chair system. I kind of have it drawn, hopefully you can see it. But the chair system is make sure that the rebar stays off of the ground. Because if you're pouring concrete and this rebar just gets smashed down and you forget to pull it up, well then it's sitting against your clay or your dirt and it's essentially useless. So we always use a chair. Plus this chair is actually, it's a smooth wire, but it's equivalent in engineering world to like 10 mil rebar. So if it cracked here, it can't pull apart this way. And the reason we use 15 mil along the footing, so if the footing is like this, is if the dirt falls away underneath, 15 mil, I don't know how many times stronger it is than 10 mil, but it's substantially stronger, or at least when you're bending it, it's a lot harder to bend. So, but if the dirt sloughs away from underneath, that prevents it from falling away, right? So when your wall's sitting on top, if your footing fell away, that's more chance for water to get in. So your 3 rows of 15 mil prevent that, and then we do 15 mil dowels. So when we pour the footings, the dowels get placed, everything gets cured. The next day or two you start stacking your wall. These are sticking up in, and we do those every 16 inches, sometimes every 24. But what that does is that holds your footing and your wall together. So then basically, like I said, it's monolithic. It's tied together. You can't, if the footing, something happens, it tries to fall away, well, it has to take the whole wall with it, you know, so it's attached. So it's way harder for anything to crack or break. In an ICF system, there's 10 mil rebar. So horizontally, so these are my horizontal bars, every 16 inches. So here, and then they stagger it. They have the snap ties are designed, so you stagger one here, 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 every 16 inches. And then you drop, when you're ready to pour, you drop down vertical rebar every 16 inches as well. So the verticals, because these are staggered, fit down nice, and then when you're pouring, they can't sit and fall against the foam, okay? So, yeah, hopefully I got my little legend here. This is the foam. This is the foam, concrete in the middle. Hopefully that makes sense. Okay, so that was number 3, way more strength. So, and even what else adds a lot of strength is these snap ties, because they hold all the concrete together. So, yeah, hopefully that makes sense. So, okay, so number 4 is continuous insulation. Okay, so I'll try to speed this up, but on a conventional, you just have this concrete wall. This is if you pour it right up to your floor system. I'll start down here. So usually what I've seen tons of guys do is your footing is here. Not everyone uses under slab insulation, but we do when we do an ICF house. But usually they just bring it flush to the top of your footing like that, and then you need less fill for your gravel. So less fill, foam insulation, and then to save space, typically they do like a 3-inch concrete slab. Okay, so this is your concrete slab right here. But you can see right away, well, you'll be able to tell when I show you the ICF system is, if cold is transferring through, it'll transfer through the slab and in that way, okay? The other place is, as soon as you start getting wood touching to the outside world, whether it's hot or cold, you get the transfer through the lumber into the house, okay? So here's what we do. Here's the best way to do it is, okay, so you have your footing over here. You bring your gravel flush to the top of your footing. Then you can do 2 or 3 inches of the white EPS foam on top of all that. Now, as soon as you do that, this insulation is touching the foam, so it's touching the wall insulation here, and that creates a continuous insulation barrier all the way around. So already you can see it's wrapped under your basement, up your wall, okay? Then if you take your ICF right to the underside of your trusses, then your floor system hangs off of the wall, so there's no thermal break, there's no thermal bridging as you carry all the way through. You have the same R value, there's no interruptions in the insulation, right? So if you look at this, every stud's considered a thermal bridge. This rim joist that goes around your floor system, that's a continuous piece of wood. Even if you spray foam in behind there, there's still cold transferring through your base plates, transferring through every stud, okay? So this system covers that, so that's continuous insulation. Okay, so 5, I had easy wiring. When you stack the next row of block on top, these snap ties are actually down about 1/2 inch. So you can actually, what most guys do is you just get an electric chainsaw, and there's a little hole at the end that's in about 2 inches. You just stick a bolt through there so that you don't rub the chain against the concrete, and you just turn that thing on and you just walk around, and you can basically chainsaw your lines for the wires, and then you just shove the wires in, spray foam it up after. But you can go horizontally, you can go vertically, so the wiring is all pretty simple. Plus the thickness of the foam allows, you don't have to get like shallow boxes or anything. It's designed, there's lots of boxes designed for ICF places now. So that was number 5. Number 6, okay, so number 6 is we use what they call, I call it sulfine, some guys call it elephant skin, but it's a peel and stick system for the outside of the house. There's lots of other systems too, but you can, well, I guess other systems you can add to this system as well. But I got my little cardboard box here that'll simulate the footing. So we have this footing, and you have your wall like this. So from the outside, you peel and stick this stuff, but you wrap it so that it goes down the wall, over the footing, and down. This system is actually considered a waterproof system. On a conventional, where they just roll the tar onto the concrete wall, is considered a damp-proof system. But like I've drawn here, the sulfine just wraps around, over the footing and down. So that way if anywhere water's going to come in, it's going to come in the connection between your footing and your wall. So the system kind of eliminates that. And it's about 1/8 inch thick, and it has this like mesh built into it as well. So it's that's a super good system. So number 7. So okay, it's way stronger. Let's just put it this way. Number 7, a 6-inch ICF wall is 800 times stronger than a 2x6 wall. So there's been lots of evidence where you see like a hurricane or strong winds or anything like that. It'll take down a house, it'll take down a paneled system house, but an ICF house it won't take down. So we won't get too much into that, but you know, you can just tell that they'd be way stronger. And because it's a monolithic system, there's where's it going to go, right? So there's lots of evidence where tsunamis, there's all sorts of houses flying around, and you know, these ICF houses are still standing. So there's that. I'll actually add to that. I don't have it in my list of numbers, but it's fireproof too. Okay, so the foam will, like if you put a flame to this, it'll go up on the foam, but as soon as you pull the flame away, it doesn't have what's the word? It doesn't support its own flame. So as soon as you take the source away, it stops. But regardless, you have a concrete wall. So even worst case scenario, if something lights on fire, you know, your floor system will burn off and your roof, but you still have the main structure of the walls and all that. So that's an advantage for sure. Okay, so number 8. Okay, so this is getting a little technical, but some of the new codes in Canada, and because a lot of guys are using acrylic stucco. Okay, so acrylic stucco kind of creates a seal. I won't get into everything about that, but the new code that I just heard about is they don't want you to mechanically fasten foam to a wall. So typically, if you want acrylic stucco on your house, you would take 2-inch foam, you would have these plastic washers that the screw goes through, so you would put, well, let's just use my wall here. You have your plywood right here, then you tar paper, do all your flashings, all that stuff. Then you screw, mechanically fasten your 2-inch foam to that, then you do your acrylic stucco, okay? But now they don't want you using those mechanical fasteners. They actually want you to glue, do a membrane, then do like a base coat of acrylic and then stick your foam to that. So basically what I'm getting at is that that would be a ton of labor, where this system, it's already built in. You have the foam, you don't have to fasten anything to it. If you want acrylic stucco, you just do your base coat, your mesh, and then if you do it properly, you do a 2-layer base, and then you do your finished color coat. But anyway, so I'm just saying that to do a wood house in acrylic stucco is probably, it's just maybe not feasible, but it is more feasible on the ICF. Keeps your labor down, all that kind of stuff. Okay, so number 9, this kind of ties with the acrylic stucco too, but not really, is, so, okay, I'll maybe just jump back over here. So on a conventional house, you got your framing, you know, you insulate your cavities, and then you do vapor barrier here, and then your dew point is at the vapor barrier. So that's why it's there, is to stop when the cold and the warm meet. You don't want that dew point and water coming into the house, okay? Well, with concrete or the ICF system, is your dew point is in the middle of the concrete, so you don't get, there's no chance of moisture coming in the house. But the best thing about that is that if the dew point's in the concrete, and if concrete's always moist, per se, it will always be curing, so it'll just get stronger and stronger and stronger and stronger over time, okay? Okay, so thermal mass. This is number 10, thermal mass. Okay, so R value. Okay, so on paper, you know, when you do a 2x6 wall, the insulation you put in there is an R20. But now, if the new calculations coming out that are actually taking the average of the whole wall system. So now it's like a U value, a unit, or, you know, the average unit. So a 2x6 wall is actually only what I would call an R13. It's a 13 value because you're taking the average of all the components, combining it, okay? So on paper, an ICF system's about an R, let's say 22 or 24, okay? But they don't calculate thermal mass in an R value calculation. So, you know, even on like a, let's say you have a panel system where it's like solid foam and there's different types, but you know, on paper it shows a high R value, but as soon as you start getting air infiltration, you're losing that air. You have no thermal mass to hold that. So the thermal mass of concrete is basically heat storage, okay? So let's put it this way. It takes, you know, it takes 1 BTU of energy to change 1 pound of material 1 degree Fahrenheit, okay? So we just finished an ICF house. It was fairly big. There was almost 200 cubic yards of concrete. So when you calculate it all out, there's about 800,000 pounds of concrete in that house. So there's 800,000 BTUs of thermal storage. So for that house to lose, let's say in the winter, to lose a degree in Fahrenheit, you'd have to lose 800,000 BTUs of energy. So if you're opening your doors, or you know, there's all that kind of action going on, it's different because you have that heat storage. Okay, so that's kind of the difference. Like if you have a wall that's on paper like an R40 but it has no mass, if you open the door a bunch of times or you have air infiltration, there's nothing to recover that. Does that make sense? Okay, hope so. Okay, so number 11, I already kind of went through this, is like hurricane or wind resistant. You have a monolithic solid concrete wall, 800 times stronger than a 2x6 wall. Okay? Okay, so it's good for soundproofing. So, you know, it's a soundproof wall. Don't know all the specs, all that kind of stuff, but You see a lot of guys using it now in condos or duplexes, the divider wall, so that you don't get that sound transfer. Because if you want the equivalent in wood framing, you have to do like a double stud wall or a stagger stud wall with all sorts of insulation and, you know, a bunch of labor intensive stuff where you can just stack some block, pour some concrete, you know, it's kind of done. Alrighty. Okay, so 13 is there are systems where you can totally get rid of any thermal bridging. So like insulated window bucks and insulated top plate. So like sometimes what you do, like on this system, you can use like a 11 7/8 LVL on the top, anchor bolted down, but that LVL is considered a thermal bridge, right? So when your trusses sit on top of there, you know, that's one small thermal bridge. But there's systems where there's an insulated window buck that is notched out, so you can have a 2x8 sitting on the outside, and then it's called HS40 high density foam, and it comes around notches. Your 2x8 sits there, you anchor bolt it down, but then you don't have that thermal bridge. So the window bucks are kind of the same. They eliminate, they give you wood attachment for your window, but designed in a way that there's no wood actually touching the outside, transferring through to the inside. Okay, so 14 is multi-generational home. So you can just tell that a concrete house is going to be multi-generational. Plus it's not going to have, let's say you build this house for yourself, you go to hand it down to your kids later on, the house is worth something. It's not, doesn't need a major renovation. There's not problems because there's wall cavities or, you know, needs an update to the insulation or anything. It's maybe just worth more in the end, and for multi-generational, who knows how long it would last, but it lasts definitely a lot longer than a traditional. So 15 is just more efficient, easier on the planet. You know, you can add all sorts of geothermal, all that stuff to this place, but regardless, even if you don't, if you just run in-floor heat in the basement and a furnace upstairs, you're still using way less fuel. It's just easier on the planet, more efficient. Because what I look at is, in the future, who knows what fuel prices are going to be. Yeah, they may be low now, but in 20 years, if you're going to retire, fuel prices skyrocket. Well, who wants to pay those utilities? With an ICF system, you keep your utilities real low. Okay, 16. So anyone who's framed a house will know this, is when you pour your, let's say you're going right up to the floor or the roof trusses. After the wall is poured and cured for a couple days, you strip all your bracing down. Those walls are set. They're not moving anywhere. So if you've ever framed, you know, for us, like say the gable end wall, the triangle end, when you're framing that, you have to make sure that wall stays braced, stays straight. If the wind comes up and gets windy a couple days, you're not sure, oh, maybe I should double check my string line, make sure my walls are straight. You don't have to worry about that with an ICF system. You don't even need exterior wall bracing. When you go to do your trusses, you just land them. You don't have to worry about, okay, is my gable end wall straight? Is it gonna move? No, it's solid. It's concrete. It's awesome. Okay. Plus, you have 11 7/8 wall to walk on. So when you're setting your trusses, it's pretty nice to walk on too. Okay, so 17 is, okay, so this one's kind of cool. So your walls won't expand and contract throughout the seasons, right? So with a concrete wall, like, have you ever noticed when your backsplash, your silicone between your backsplash and your countertop is always cracked or pulling away? And that's because on a traditional wood wall, that wood wall is always shifting with the cold, the humidity, the warmth, so it's always pulling in and out and causing havoc on that, and that's just kind of an indicator of that. So once you pour your concrete wall, you do it properly, you set it straight forever, it doesn't shift around, cause issues like that. Okay, so 18 is no cavities, so you don't have cavities like wall cavities for mold to grow in. So it's straight system. Drywall sits up against. You do need airflow, so I might as well throw this in right now. Like what we do is in a basement, we do an HRV and in-floor heat in the basement. You could get into all the specifics on that, but then we just, for cost, we just run a furnace on the main floor and it keeps everything simple. But you need airflow with this because it is a tight system. But because the foam itself is an inorganic material, it won't sustain or won't allow for growth of an organic. So a mold isn't going to grow from this because, or an organic isn't going to grow on an inorganic substance, or that's what I've been told. So okay, so number 19, you can pour these walls in the winter. Obviously if it gets too cold you don't want to, but regardless, like if we're pouring footings in the winter, yeah, we'll cover them and heat them for at least 7 days. But with the wall, all you have to do is tarp the top of it. The concrete has its own heat because it's a chemical reaction, and then the foam contains that so it can cure and you can still pour in the winter. If you pour conventional, if you do want to hoard it in and heat it, it's a heck of a lot harder. But yeah, I don't think most guys do that. Anyway, you don't want concrete to freeze. Let's just put it that way. So number 20. So rough-ins can be completed in the winter time. So there's kind of a theory. Well, let's just talk about it. If you're doing winter construction and you have this whole system, all your rough-ins need to be complete before you can start throwing heat to it. Well, actually, on a conventional, all your rough-ins have to be done, then you have to insulate, then you have to poly, then you can add heat, because it's too hard. There's gaps, you always have to put gaps in your plywood that you'd never contain the heat. With an ICF system, there might be a few days where you don't have heat, but what one guy does that I know is, your walls are up, you get your roof system on, then you get it wired. There's a few days where you don't have any heat, but as soon as you get to the point where you can poly the ceiling, what he does is he puts 2 inches of foam on the ceiling. He does that so then he can start blasting the heat right away. Then you can finish all your rough-ins. That eliminates thermal bridging from your trusses down through your drywall, so that's one advantage to that. Then you can drywall the ceiling, do your blown-in, but you can still have heat before all of the blown-in insulation gets done in the attic. So hopefully that makes sense, but it's definitely a lot easier to heat in the winter. Okay, and see, I'm told you I'm over 20, I'm into 21. So, oh dang, how do I explain this one? So, because you have a 11 7/8 wall or 12-inch wall, when your truss comes up and then slopes like that, you have way more insulation sitting on top of your wall, right? If you only have a 6-inch wall, there's less insulation above the wall. So I hope that makes sense. It's just simple. It's right as your roof rises, you have 12 inches, there's way more insulation sitting above there. So I'm sure there's some more advantages I never thought of. 21 is where we're sitting at right now. That's it for now. Thanks for watching. If you enjoyed the video, please subscribe to our YouTube channel or check us out on some of the following.